And very good. So hello, good morning, good evening, good afternoon, depending on where you are. Welcome to Kubernetes SIG API Machinery, bi-weekly meeting for Kubernetes open source. Today is June 14th, 2023, and we are getting started with a number of items in our agenda. So let's begin with Stefan, I think, representing Mike too, hopefully, about this.
Yeah, I haven't heard him, so
very good.
It's not here. If you can click there on the cap, so it's a cap. I think we have been talking about that at least for half a year, maybe even longer. Actually, much longer, because this is about config or option config server, and most of you will know this pattern from lots of our repositories like API extension and KNS API server. All of those are built on that pattern. And this is a cap to extend that, basically finish the work we have started years ago into Kube API server. Kube API server is one of those components which is not really modular in how the plumbing is implemented. And the consequence is that we're using parts of Kube API server, for example, for generic control planes, so control plane usages which are not container orchestration related. It's hard. Like, it's possible, people do it, but it needs lots of plumbing code. And this cap is about finishing that work, splitting up how the Kube API server is instantiated in code. Everything here is about code. That's very important. It's not about building or delivering a generic API server as part of Kubernetes. That's not the goal. That's a non-goal, actually. It's written somewhere there in between. This is about enabling our factoring, the libraries we are building for consumption, for use cases which exist, where people work around, but just to make it easier and participate, or make it possible that those parties can participate in the project. If you move down to the picture, maybe that's the best way to illustrate what this is about. So this is basically the dependency structure, dependency topology of the main repositories, the main staging repositories around API server. So API Machinery and API is there, client Go, API server itself. And at the bottom, there's KK. So Kube API server, Kube controller manager live in KK. So the command and the packages are living there. And they depend on staging repositories, but consuming those is just, it's tricky, it's messy. And the suggestion here, the proposal is to add one level in between. So it's called generic control plane. There's a discussion, like a small bike shedding discussion we started further down. But basically, a generic control plane, maybe two of those repositories, which sit between, and they will include everything which is necessary for generic control plane. So control plane is always API server plus controllers. That's the idea. So things like garbage collection, namespace deletion, maybe a CID, so API extension, API server, those things belong to a control plane. And generic, because there's nothing specific inside. There's no pod, no node. All those things stay in KK. But we want to move those generic pieces into generic control plane. As I said, we don't want to deliver a binary. So there's not a one size fits all binary like Kube control plane we want to deliver. There is no one size which fits everybody. So it's a little bit like embedded systems, where you also have to adapt things, and they differ here and there. Some people want airbag authorization, some people don't. Some people want secrets, some people don't. So those things should be configurable in this library, but in a very simple way. So using options. If you don't want secrets, just change your Boolean and it's gone. That's basically the goal of simplicity here. And if you move to the goals again, maybe.
The goals?
Yeah, the goals. The first one, maybe to call out the first line here. This will change plumbing. Like, we will change the options, for example, split them up and do similar things. One goal is this should not change the overall structure of Kube API server. I mean, the plumbing will change, but the PRs should be pretty obvious that they just move stuff around. So it should be obvious. And we have done first steps already. This is possible. Splitting up what is in Kube API server, having a generic part and having a non-generic part. But it should be obvious that the result is basically the same. So we don't touch any behavior of Kube API server. Same thing for controller manager as well. What else is important? I think most things I talked about already. Yeah, maybe the last goal here, the last line above non-goals. The factoring should not be prescriptive about the binary topology. So Kube API server obviously is just the API server. Controller manager, it's its own binary in Kube. We had Hypercube in the past, we didn't like it. But this library, it should just allow composition. So if somebody wants to compose API server and controller manager, like some projects do, like Microshift or K3S, we don't want to encourage it, we don't want to discourage it. It should be just agnostic to those things. So, and the options config server pattern will just allow that. Non-goals, yeah, as I said, we don't want to deliver something one size fits all. That's not the goal. There's no zero change in behavior of the existing binaries towards the user. We want to deliver a sample. Maybe that's the most we do, like a sample control plane that's just proving composition, that it works, that plumbing works, and shows people how to use it, but it's not used for production. So it's really just one configuration. That's it. And the last thing here in the non-goals, we don't want to make a staging repository for Kube API server. I mean, maybe that's another step, but this CAP doesn't care about that. It's not about those steps to get rid of KK. That's not the goal. All right, I think now I have talked about most important pieces.
There's a hand from Mo.
Yeah, I just had a question on that diagram earlier. It made it look like Kube API server would only depend on control plane. It would no longer depend on K/API server. Is that like intentional?
It's transitive. I mean, of course, it will depend on everything else. I avoided all the arrows which are implicit.
No, I was more asking, so like, will it still have direct imports of API?
Yes. Yes. Every transitive arrow here is possible and will stay. We don't change that.
Okay.
It's really just about moving. It's about moving packages from KK into a staging repository. That's all.
Okay. Thank you.
So I think this is a really good idea. I've thought for a while that the basic API server is insufficient for what a lot of people actually want to do when they want to build like KRM control planes for non-traditional Kubernetes uses. So this makes a lot of sense to me. I think this is a good split. I like that we're specifically calling out that we're not going to put like another Hypercube back in, but I think it's fine if people want to do that out of tree, whatever they want to do. We also, I think we did talk about this briefly, like maybe 2 months ago, and I think the general consensus was that we did want to move forward with a cap on this. So we've already kind of pre-agreed to the idea, and I think this implementation is pretty reasonable. I like that we're getting the CRD, the namespace, garbage controller, a bunch of stuff all in one place.
Yeah, I mean, there will be details in the, I mean, I put a sketch, if you scroll down a bit, about packages. That's not the final word. I think lots of that will just develop while moving, where it makes sense, where we learn that things can be split or can't be split. So it's a sketch.
Yeah, I don't want to yak shave on it too much, but I do want to make sure that we don't have too much like fan in, fan out on one component. But I think logically, this is the model I want. So I'm supporting this.
And maybe the approach will be, so we have the package control plane and package Kube API server. We will try to move there and split there in the beginning until we have a structure which is separated enough. And then in one big step, we just move the stuff in the staging repository. So to avoid noise, basically.
Yeah, that sounds good. And it'll be pretty obvious when we're looking at these PRs, like if the dependencies change in too extreme of a way, that would kind of be a hint to us what to watch out for. But this sounds good.
Maybe a last word about roadmap timeline. The work has started, so we are already splitting up stuff. One PR merged. There is no need for pressure, like it's finished when it's finished, I think. So there won't be a complete split probably for 128, probably 129. I'm not sure alpha beta makes any sense here. Functionally, nothing changes. So if tests are necessary, of course, those things we can talk about.
Yeah, I think I agree that like there's no feature gating. We're just done when we're done, and you couldn't really, I don't think there's a way to say that a staging repo is beta when RGA features can depend on it. So it probably doesn't, that model probably doesn't make sense.
All right, thanks for the feedback.
Yeah, so Stefan, out of curiosity, what are the, like, there is no, I understand this is a big change, but there is no milestone yet. So what is the plan? You said like, I see some, initial PRs start to merge. So
if we agree on the direction, I mean, the deadline now for CAP is these days, right?
Yeah,
2 days away or something.
Yeah, tomorrow.
I'm fine with putting it there if we agree on that.
Yeah, I think it sounds like you would like to make forward progress in 128, and I don't think there's any reason to block that. So I will do it a final read today. If anybody else would like to jump in and put an opinion on stuff, please do so quickly. I don't know if we need PRR on this, but we probably have to check the box. But yeah, I'll be ready to get an approval on it probably later today, and then let's make sure we get a PRR reviewer.
Cool, thanks.
Thank you. Very good. Okay, so moving on, Jeffrey, it's your turn. Jeffrey, you there? We can hear noise, but not your voice.
Wait, sorry, can you hear me right now?
No, we can't hear you.
Let me try to join.
Looks like he's trying to join again. Wind tunnel, yeah. Or, the wrong microphone. He left the AirPods on the kitchen or something, and he was talking from the office. Happens.
Can you hear me right now?
Better, yes.
Better?
Yes.
Okay. Cool. So today I'd like to talk about lazy OpenAPI aggregation and CRD building. And to provide a bit more context, a while ago we introduced this idea of lazy marshalling to the OpenAPI, which drastically reduced or improved the performance of the Kube OpenAPI servers on cluster installations, especially for clusters with many CRDs. And since then, we've refactored this sort of lazy mechanism, to be more generic, into this caching library. Thanks, Antoine. And this sort of allows for reuse across different components in Kubernetes. Now, despite the performance improvement, right now the performance improvement of the performance of a Kubernetes cluster during the installation of many CRDs is still not that great, especially with projects with a lot of CRDs like Crossplane. And so we're trying to propose extending this compute on demand model from just marshalling to the entire creation and aggregation process of the OpenAPI. What that looks like more concretely is here's a before diagram, which is we have a controller that runs and checks for both local and aggregated API services on a set interval and aggregates the OpenAPI there. And basically all that OpenAPI is stored in memory. And when a user fetches the OpenAPI, the only process that's done lazily is the marshalling step. So marshal is done on demand, everything else is eager. What we're proposing is in the after step that the entire process of building the OpenAPI aggregating and marshalling is all done lazily, such that all these computations are performed when a request to the OpenAPI endpoint is sent, instead of doing it whenever, let's say, a CRD is applied, etc. Now we note that aggregated API services, since we don't really have much information about their availability, latency, we don't want that to be factored into our sort of SLOs. So we'll continue with the current approach of having this controller run on a 60-second interval to fetch the aggregated API services. Okay, going down to the results. I'm sorry, do you mind going down a bit? Yeah.
I'm there.
So I have a work in progress sort of branch for this proposal, and just showing some numbers. After installing a set of 200 CRDs, this was obtained from the KCC repo. We found that the in-use memory decreased by approximately 36%, and memory allocs decreased by like 23%. And this is because it's lazy. This memory measurement was measured after the CRDs were applied, but before a request to the OpenAPI was sent. And obviously, like after the request to the OpenAPI sends, the memory is not that much different because the operations are still the same. We're just trying to make everything more lazy. So one drawback of this approach is that the initial request to the OpenAPI, because we're making everything more lazy, it's going to increase. And in this case, it increased by about 300%, which is from around 0.25 seconds to 1 second. And this is only on initial request to OpenAPI because we do things lazily and we cache things. Subsequent requests to the OpenAPI are still extremely fast at less than 10 milliseconds. And so the main goal of this is to smooth out the memory spike from installing many CRDs at once. And at least on the test cluster, I didn't really have any situations where the API server starved for resources. But in things like GKE, etc., there are a lot more instances where the memory spike that occurs from installing many CRDs can cause an out of memory and an API server restart. And so right now we're trying to trade this performance for a hit to the speed of the first OpenAPI request while trying to improve the performance of this memory spike phase when installing many CRDs. I have a bunch more notes afterwards, but I think I'll just stop here for now and see if there's any feedback, comments, etc. Okay, so the main thing I just wanted to sort of get out of this meeting was if it was okay to sort of move forward with this approach. This idea of trading the like performance hit on the first request of the OpenAPI to increase the memory performance during installation of CRDs. Stefan?
Just a question. Do we have any metrics how many V2 requests actually exist nowadays, like old kubectls which are out there or something? My gut feeling would be it's just not used, and those 300% don't matter. I mean, don't matter in the. It's worse than before, like in numbers, but we should go forward.
Yeah, so we do have. I know Sean created a list of endpoints that still use OpenAPI v2. We're trying to move away from it, but right now I think we still do client-side validation, which is probably one of the biggest users of the features of the OpenAPI right now. But yeah, there are no more comments. Thanks, everyone.
Sorry, I was just sorry, I was muted there. I think it's probably okay. I'm a little curious if there's anything easy we could do to kind of like pre-warm that system for the first request, but I don't know, like it's not that slow. Like clients should time out, and if they do, they retry, then they're good. So I don't know. I don't feel super strong about this.
In this
Antoine,
sense, could
as
it
Antoine
be?
mentioned,
Antoine,
sorry, go ahead.
is your point that the whole benefit is that if you never use it, that's where you get the memory win?
Yeah, that's kind of the idea behind that.
Yeah. Okay. Yeah. No, I think I can live with this.
I have a question. If a client simultaneously requests OpenAPI for many CRDs at the same time, do we have the same situation? Say you have a malicious client or naughty client.
So this would only be the case where if there are changes. So in the case that I actually made a note in the sort of interpretation section, which if there's nothing changed, we use e-tags for everything. So we basically compare the e-tag, we have a cache version, and we serve directly. We don't really need to go through that entire aggregating computation process.
I guess I'm curious if it's been explored to have rate limiting around this computation, and basically instead of trading first request latency, we could trade possibly time to establish, or maybe that doesn't work because then if the schema changes, you're already established. So maybe I withdraw that.
I'm not sure if I fully understand, but if you want to make a comment, we can discuss further in this doc.
Sure, thanks.
Okay, no more questions for Jeffrey, no more comments. Very good, thank you, Jeffrey. Okay, so next one, I think it's Mo.
Yep. So I wanted to bring this up because it kind of came back on my mind with the universal version proxy thing that's in flight. So we're starting to mature the StorageVersion API, and inevitably it will have to graduate towards other things that are depending on it to meaningfully make any progress. So I wanted to ask if there was appetite or interest in having something like what SVM did, but in tree and KCM, and if so, what do folks think it should do?
I think it's needed. We're still at this point where like you can have arbitrarily old objects in the system. Right now, there's no way to guarantee there's not some cluster with the oldest introduced, version of anything in storage. And so we keep all of the alpha APIs around for storage internally in the API server. So it seems like it would be pretty amazing if we could actually start making real progress on this.
Yeah, so I agree there. So to me, something like MVP for something like this would be the ability to be able to guarantee that maybe per release this happens as like a minimum, and maybe the ability to let the cluster admin just force it if they want to make it happen again. Those are sort of the two things I had in mind. On your hand.
Yeah, I was actually thinking it might be nice if we actually formally introduced the concept of mixed state awareness into the API server, so that basically we can detect version boundaries, and then we could possibly kick this off automatically.
So you're saying that instead of it being just on some kind of timer, effectively, that's based on things kind of moving forward, there would be more like schema awareness per resource, so that way the skew would be more obvious, and thus you could kind of run
Well,
it.
I was actually thinking like maybe in the process of graduating API server identity, we introduce versions, and then we could watch on those objects to determine when we enter a mixed state field, and then we could kick off storage version migration.
Yeah, there's the mechanism, and then there's I think at a high level what we want. I mean, one thing that I would really love to have would be the ability for us to eventually say Kubernetes version 130 is guaranteed not to have like really old stuff in storage. That's actually pretty hard to do because you would have to have some kind of guarantee that you'd actually finished some migration before doing an upgrade to a particular version. That would be a pretty amazing long-term goal if we could get something like that in place where you actually get a guarantee that some old version of storage is like completely gone and we've moved on.
Yeah, I suppose there is the concern that if you do very quick upgrades from one version to the next, that the upgrade hasn't completed. But I suppose we would solve that with some kind of status indication that is only written at the end.
Yeah, I'm in no hurry to actually get rid of the storage version support in the API server yet, but still getting something in place that we believe is actually like forcing things up and making it part of the upgrade process. Like you're not really upgraded till 130 until you finished these storage migrations. And we don't really want you upgrading past that until that's done. Getting that working and getting that working with skip upgrades and LTS sounds hard, but that would be like an actual win.
Yeah, that's fair.
Short of that, I mean, it's nice to run it, and I think it is good to start moving it into the system. Like it would still be a win if it was just a default thing that everybody was running, because you would get performance benefits from not having to do nearly as much conversion and all that kind of stuff. I think Stefan, do you remember? Are we switching CRD storage version now? I can't remember.
No, we didn't, but it
No,
has special reasons.
Yeah, there's special ones, but like there are ones that like there might be a lot of, and so there might be benefits to users in certain cases.
Yeah, so for like the motivating factor for me is I want to be able to do storage migration for key rotation for encryption at rest. And I don't want to tell people to like run SVM, and I don't want to tell them to use kubectl. Like this is incredibly manual. Like I'd be okay telling them issue this one kubectl command that tells a controller to go do all that for you and then just check the status later, because I can basically completely automate that and make a UI around it where people just press a button or something. So that, that's sort of the angle I'm looking at it. So for me, it can't just be purely automated by schema changes, I guess, or API version changes, because key rotation can happen arbitrarily internally, right? So I do need like a mechanism to at least just do it one off.
Yeah, I can't think of any reason why we couldn't do something in the KCM. I also asked David before this meeting, because he couldn't be here, if he saw any problems with it, and he didn't see any problems either.
Okay. Yeah, I guess let me ask this question I asked again earlier. Like, what do we feel is like bare minimum MVP? Because I feel like I went through the list of the old efforts we had, and like there's like 5 of them, right? So I'm really nervous about trying to solve all of the problems at once. I would much rather just move the current state forward and then have another KEP or another KEP after to like
Sure.
further.
Yeah, forward progress is a fair thing to do here. I feel like if you could run a storage migration and know that it was done, even if you had to manually kick it off, but it was part of like the KCM and you could manage it in a very same way, that seems like pretty good progress, right? Even if like you still have to tell somebody like, somehow you have to set up the migration be running, but you get to know when it's done.
Mhm.
That
So
seems like forward progress.
What is missing in StorageVersionMigrator? It has that, right? There's a CID migration something, which gives you feedback, so you know.
Well,
So
okay.
anything.
I forget exactly the state of all the APIs in SVM, but part of this is for me to make this more viable is actually moving it in tree. Like, yes, the component exists, but like if you moved RBAC out of tree, I don't think people would be particularly happy with you because they think of it as like a core part of the system, even though it's completely optional. Right?
It's less, it's convenience basically. Plus, we can rely on it. Like encryption can rely on it.
Well, yeah, convenience. I can rely on it for core things in Cube, and I also want people to do it. Like, I don't think anyone does other than like OpenShift. I guess I don't actually know anyone running SVM other than OpenShift. I'm sure somebody is.
Stefan, would you see this as being part of the generic Kube API server?
Yes, I would say so.
Yeah.
So
I mean, I think it's reasonable to start moving again.
Okay. So let's see. When you guys originally built this out, how happy were you with the REST APIs associated with it? Were those like they never made it to beta officially, so I'm kind of curious what prevented that.
I don't know if we have the right people here. Unfortunately, we don't have Chow. I think Daniel might have known some more history. I don't know enough. Does anybody else know?
I think the reason is just that there was no pressure to promote, to work on it. It's used by OpenShift for years now, so it's stable, it does its job. Of course, a bike sharing discussion can be done right on the API. Maybe there's something missing people want.
Okay. So I mean, I guess we could technically move those things in tree as alpha, basically as is, and then bike shit away on a cap on if we're happy with them before any promotion. Like basically we can pretend like SVM didn't happen and just start it from scratch, but go through all the standard process and let everyone make sure it's all perfect.
I think
that sounds pretty reasonable to me. I don't know what API review wants to do though. They'll definitely want to look at it. I don't know to what level.
Okay. I think I'll write down some notes here, but I think that's good for me.
Okay.
Thank you.
Okay. Thank you, Mo. I don't know if people saw my comment. Somehow looks like this account is turning into a free account. So we have 3 minutes left, and I saw Shane, you added a topic, which I will allow for this time.
No,
Usually,
3 minutes. 3
yes.
minutes won't be enough. I'll bump till next time.
Okay. I mean, we can probably the meeting will end, and I can start it again, and we can join back. But if your topic can wait, we can.
It can wait. When's the next meeting?
2 weeks.
Yeah, I think it can wait the 2 weeks. That's fine.
Okay. That sounds great. Thank you. And sorry for the account problem. Like I had no idea. I was checking my email. There is no warning. So I will figure it out for next time for sure. Very good.
That's okay.
Well, thank you everybody for coming and participating. I will upload the meeting later today, and we'll see you in 2 weeks. Sounds good. Thank you.